Hello and welcome to Washington Exec's video series. I'm your host, Amanda Ziadeh, and with me today is Tommy Gardner. He's the Chief Technology Officer of HP Federal. Thank you so much for joining me today, Tommy.
Happy to be here.
Great. So we're here to talk about the future technology landscape. So my first question for you is, what do you think that looks like in terms of tools, solutions, or technologies?
Well, I get my crystal ball out. It's often very cloudy, but there's some things that are very clear directions that we're taking.
Mhm.
And there's certain areas that we focus in, and we invest heavily in improving our products every year. And the reason we do that is because the threat that we see in the cybersecurity landscape is investing heavily to get better. And if we don't keep up, we're going to fall behind and just be an open book. And so the future technologies are going to be critical in our markets, or such things as cybersecurity. It's events like the supply chain and how you manage and mitigate risk in your supply chain. And then it's also some little things, and it can be your display technology and how you can have a bright display and have a laptop that you can work out in the full summer sun and yet still have visual acuity and understand what you're looking at, not have to hold your arm up above your laptop or shield your eyes. And so it can be, little innovations like that that can make additions. The sound system. People have gotten used to theater quality sound, and can you do that on a small laptop computer that weighs 1 kilogram or 2.2 pounds? And the answer is yes, you can. Now that's absolutely amazing. And 10 years ago, nobody would have believed you if you told them you had that. And so what will the next 10 years bring? And I think there's going to be quite a plethora of new innovations that come, and it's because companies like HP are making investments every day, trying to get better, trying to make better. So we're, if you look at the numbers, depending on how you want to count, probably about $3 billion a year, plus or minus, and that are into our HP labs, into our look at the future, and some things that we do. Probably one of our most exciting things we came out with this year was OmniSet. So it's an AR VR headset, and normally you think, well, that's cool, but that's for gamers. That's for people that are really into three-dimensional gaming and either on a quest or you're hunting and shooting something, and and I'm not a gamer, but the video is so impressive that it's looking at a camera within the concept that's looking at your eyes and tracking where your eyes are going. And that same concept can be used to determine medical conditions, and it will determine your pulse rate because the eyes, if you look closely enough, there are blood veins going through them, and you can see them pulsating, and you can get a pulse rate from that. So you can see if somebody's getting excited. And even one twist of that software, the predictive analytics that you get from machine learning, deep learning, which are all part of artificial intelligence, it is you can actually look at a Zoom call like you and me and determine, is the person paying attention? What is the emotional state? Amanda, are you happy?
Right.
Are you listening to what I'm saying?
Mhm.
And I can think of applying that in a classroom situation.
Uh-oh.
So I'm gonna be teaching at the graduate level at Catholic University this next semester, and teaching courses on cybersecurity and in supply chain risk. And I'd love to have the video, because it's all remote these days,
Right.
of which students is tuned in and which is tuned out. And maybe something like that can help improve our teaching rates, because you can realize that when you're teaching calculus and the students are just have a blank stare, they don't get it. Let's get back to the beginning. Let's go over this one more time. Can I approach it a little different? Can I give you a different example so that it starts to gel? Is somebody angry or is somebody happy? You get that visual feedback when you're face to face, and intuitively your mind processes that information. But the software can be 80, 90% accurate. Who knows? So there are things like that that are coming down the streams. I think the most important thing in our markets to protect both the data and intellectual property we have, but also the privacy of individuals, to make sure that people feel safe and secure, that their personal lives and their personal digital trail is not being invaded or captured or used against their will. It's going to be that cybersecurity realm. That drives to a zero trust model. HP's been doing zero trust for over a decade. And people think of zero trust of how you look at your data and how you treat your data. Do you encrypt it or not? But our zero trust is built into the architecture of our machines. And a lot of people will look at a laptop or a desktop and say, well, they all look the same, so they all must be the same. But they're not the same. They're not by a long shot, because it's what's inside and the way they were designed and built, and the engineering trade-offs that have to happen between the size, the weight, the power, but the security. Those are important. And we at HP take security as the prime directive. It's the number one. And your first thing is to build the most secure machine, and then you look at the size and the weight and the power and the rest. So things are changing in the markets. The machines are getting smaller, and I mentioned our 1 kilogram or a 2.2 pound laptop. We've got the Firefly, and now we're coming up with a workstation, which is a real horse of a powerful machine. And it's built just like the Firefly. It's called the Dragonfly, and it's made of 80% recycled plastics. So it drives to sustainability is there. We're looking at lowering the power. HP has been following the Paris protocols over the last 5 years. Although the country up to date has not, we see the need for building a sustainable company that follows environmental practices and procedures. And we had a goal to be net zero paper by 2025. And that means that if we're going to be printing paper or using paper or selling paper, that we're going to be planting trees to grow that back, so that there's a net zero return. We're not decreasing the amount of wood resources, but we're keeping it even, or maybe even growing it, depending on how many tree forests are put back into the system that collect the carbon dioxide, that keep the greenhouse gases down. And so 2025 was a stretch goal, but we achieved it this year. And so 5 years ahead of schedule.
Amazing.
So it really is impressive. I'm so proud of our company. We're ranked in the top 10 in supply chain capability by several different sources, independent of HP. We're, I think, number 7 on the most environmentally sensitive companies, top in our market, but just in all markets. And I attribute that to our leadership. Enrique Lopez, who took over as CEO a little over a year ago, has really driven the company towards values, and a value-based company. So I've been here 4 years now. I'm in my 4th year at HP. I love the company, but most of the people I work with, most of the senior executives, have been here 20 plus years. My good friend and my partner in HP Federal for our Department of Defense work is Mark Prather. Mark just turned over 40 years at HP. Wow. And, he wouldn't consider working anyplace else. I don't think he ever has worked anyplace else. And I love the company. I can see why they feel this way. It's just a great place to work, top quality people, but we have goals and missions that are broader than just selling boxes. It's trying to make the world a better place and trying to address the needs of the broader community.
Well, wonderful. Talking about those needs, and I did want to go back to something you said about the virtual education and virtual workplace, that is currently our situation. Is the current work from home environment shaping or impacting this future technological landscape at all? You talked about security. I'm sure that has a place in it as well.
Yeah, no, absolutely. We had one of our best years ever this year.
Mm.
Our fourth quarter earnings just came out a week or so ago, and the people at HP have been busy, and so supply chain's been a focus because we need to keep pulling in from our components and our suppliers the components that are needed to keep building these machines. We can't build them fast enough. If I remember the numbers correctly, we're making a personal system, either a PC or a workstation. We're making 1.3 every second.
Wow.
So that's like 4 in 3 seconds. It's there's a lot of them just going through the factories, and we're keeping the top level quality and made from the best design. We're making a number of the parts with our 3D printers, which is a new market we're in, and we're at the top of that market for small scale manufacturing. In fact, one of our newest 3D printers, really impressive and somewhat scary, but 80% of the parts on our newest 3D printer are made by a 3D printer. And so, starts to sound like, something out of an Arnold Schwarzenegger movie. It's Terminator come to life.
Mm-hmm.
But when you think of it, well, that makes sense because you're not transporting things all the way around. You're making it locally. It's an objective to bring manufacturing back to America. Here's a method to do it. And so if the first 100 3D printers you make are just to make more 3D printers, that's a good thing.
Right.
And they're very popular out in the manufacturing space because they're so flexible. They can make so many things. They do it repetitive with the same quality every time. And so I can see that impacting the workplace of the future in the manufacturing spaces and trying to make things. We have a project. I had a summer intern. She was environmental science as an undergraduate. She's currently in an MBA program named Shannon Lee. And she worked with me on the U.S. Council on Competitiveness in our sustainability study that we're doing at the council. And she's been promoting this idea of a net zero factory. She took the term net zero paper and thought, can we make a factory that doesn't use energy or doesn't use non-renewable energy?
Right.
And so one of the thoughts was, well, you got sun and you got solar, but they're not dependable. You got to put them in a battery technology. And there's such thing as an earth battery, which is a molten salt battery, works very well and applicable for remote areas. But she said, well, if we're going to put this thing in the Midwest, where there's a lot of dairy farms, why don't we use the waste from the dairy farm, the cow manure, to put it bluntly, and turn that into a reactive device that creates energy, that creates steam, and use that power to power 3D printers that are there in the middle of nowhere. And you can control the 3D printers from Timbuktu. You don't have to be there directly.
Right.
A lot of the jobs are going to be high-tech jobs, typically well-paid jobs, to maintain the machines and to take the trays from one 3D printer to another. There's still some manual work that has to go on. It's not quite the lights-out factory, but in the future it could be.
Right.
Nothing prevents it. The technology is there. It's the application of the technology in new ideas, in new applications. And generally, the way that works is you got to take people who have different backgrounds, and that gets to our real thrust in diversity. But if everybody thinks the same and looks the same and acts the same, you're not going to have any real new ideas.
Right.
But you bring in people from different fields. My doctorate's in economics. Hers was environmental science. We're working with a physicist out of HP Labs, David George, and he's an electrical engineer and a physicist in grad studies. So I was a mechanical engineer and I went into economics when I got to MIT in grad school. And wow, I mean, we all think different,
Right.
but it's that difference in thinking that brings together, makes a strong company. And our CEO is committed to diversity and bringing in people from different locations and organizations. And I think that's really good for the company. Where most people have been here for their whole careers, like Mark Prather, the 40-year veteran in DOD. I've been in the Navy and government. I've run programs in government. So I've been on the customer side. Right. And then I've worked at 4 different companies as a CTO before I got to HP. And seeing how different people in different companies approach problems different ways, that's a very valuable insight to bring to the HP leadership.
Yeah, and considering, all the insight you bring, all the innovations you've discussed, and the market that you are in, what challenges do industry and government have to overcome in order to, meet those technological advancements and keep up with the pace of technology and customer needs?
Yeah, it's a constant challenge, both in industry and government. The first challenge is an openness to change. People resist change, and for good reason. There's anxiety. It's if you like where you're going now, you don't want to change because you're afraid it may be worse. The grass isn't always greener on the other side of the hill. Sometimes it's dark brown, and you want to go back to where you were. So it's that openness to change, because in truth, most things that you change can be an experiment. And if it's not working, you go back to the way it was.
Right.
And David Packard said something very prominent when asked by a reporter, what's better in an organization? And he at the time was the Deputy Defense Secretary. He had taken a leave as the CEO or co-CEO with Bill Hewlett at HP. And the reporter was asking him, hey, you came from a very matrixed organization at HP where everybody has access to everybody. It's an open door policy. You work together to a goal to help improve the company, and you have a report structure, but nobody really knows what it is. I don't think I've even seen an org chart since I've been here. It's a very matrixed group, to a defense department, which is very hierarchical. The 4-star generals over the 3-star general, and it goes all the way down to the corporal and the man in the ranks. And David's answer was very astute. It was, it really doesn't matter. But if you're in a hierarchical organization, you ought to consider going to a matrix. If you're in a matrix, you ought to consider going to hierarchical, because the organizational structure to get things done, they both work. They both can work. But the truth is, in the change, it makes you consider why you're doing what you're doing. And it's that thought pattern of, we've always done it this way, that can kill innovation. And so how do we keep innovating? And particularly in the world of the pandemic we're in, we've put a lot of effort in focusing in what we can do to support the pandemic. Our 3D print machines have been making face shields. Right. Very fast, very accurate, and very comfortable. If you got to wear one all day, you want it to be comfortable, or you're probably not going to wear it.
Exactly. Yep.
Take it off as soon as you can. So one of the things we've started as a new business line, our 200A business, and it's named for the first HP product, but it's taken our knowledge in microfluidics and applying it into the healthcare field. And so the ability to test for a pathogen at 1,000 times faster than the tests can do now. We can do this at picoliter range. And a picoliter is, very, very small sample size of a fluid. A blood drop is, thousands of times bigger than a picoliter. And so our knowledge of fluids, where we can put 8 billion drops of ink on a page of paper every second and put them on the right place of the paper at the right color, that's just an unbelievable problem that we solved. And applying that knowledge and intellectual property and the scientists that know how to do that, both in control systems and the chemistry of color and the injection at a very high speed of paper flow for press production printer. That's the thing that, when applied to a new field like healthcare, you bring in some healthcare professional, you bring in some control system electrical engineers, bring in some mechanical engineers and maybe a few people that understand the 3D print process. And you mix them together, and what you get out is a whole new product.
Right.
And we've come out with that. And the first product is called Florence, after Florence Nightingale. And it is, I think you're going to see it in hospitals all, not just in our country, but all over the world, because it helps to test, and not just a COVID virus, it can be programmed into almost any virus. Mm-hmm. And when you start thinking about programming using fluid controls, is the new ability to manipulate very, very small drops of fluid, kind of like a new transistor was 50, 60 years ago, mm-hmm. where people haven't even thought of all the applications the transistor could use. Mm-hmm. And now you got a billion of them in a machine, or several billion in a machine that weighs less than a kilogram, mm-hmm. and doing all sorts of processing and analytics. I think the next big wave of change that we're going to see is in the quantum information science field. And there's some companies out trying to build a quantum computer. We're not doing that yet. One day we may be. But today we're looking very hard at a quantum internet, how to use quantum properties to create a new internet that's protected by secure methodologies. If you use light or photons, single photons, to send information, and you're depending on the polarity of those photons to create a key, and somebody is trying to look at what you're doing or steal your information, they're going to change that polarity, the key won't work, and nobody gets any data. Mm-hmm. Now that's secure. Right. The first generation internet that we're on today, the IPv4 and IPv6 protocols, they weren't designed to be secure. They were designed to transmit information and share information to a broad category of people, particularly the DARPA scientists and the universities that they were working with. Right. If we generate a new one, I think we'd have a much bigger concern and bigger focus on the security such that data is protected. And so innovations like that, they're going to be exciting new parts of the future. And from what I see in my crystal ball, they're not that far away. They're going to be here before you know it. And you're going to wake up one morning and read some report that they're here. The Chinese government has been investing significantly in this field. The U.S. government is catching up, but we got a long way to go. But I read this morning, I woke up and I had an article on my phone, and it was about the Chinese using these photons in a quantum computer to get quantum supremacy, meaning they solved a program that would take a supercomputer 10 billion years to solve, and they did it in 3 minutes. Now, that's impressive. Right. I was asked earlier after reading this and sharing it with some friends, do you think it's true? Well, I think there's truth. The media tends to fact check things, and I think the claim is probably fact. But there's other hurdles that have to be overcome. Were they able to do it once? Is it repeatable? What about error correction in the calculations? Will they get the same answer every time? And so those are questions that they didn't address. But and it was in an article in Science magazine, right? Which AAAS, the American Association of Advancement of Science, supports this magazine. So I have no doubt that they did some fact checking to make sure that the reports were accurate and based on scientific principles. Mm-hmm. And so things like that get exciting.
Mm-hmm. Absolutely. Yeah. Well, thank you so much for sharing all of these insights, into the technological advancements not only HP is making, but the industry itself and how it relates to your market, the federal government, and us, in the future every day.
Right.
So.
Well, our motto here is keep reinventing. Mm-hmm. And so something that was invented once, you can always build a better mousetrap.
Right.
And that's what we're trying to build, a better computer. We're trying to make it lighter. We're trying to make it faster. We're trying to make it use less power. We want to make it more sustainable. And with all that, we'll have to come back next year and tell you how far we got.
Right, exactly. Thanks for catching up with me today. Really appreciate it.
Yeah, thanks, Amanda.